So today's lab is very, very much like the lab we did on Monday. Okay, we're still going to be whirling the rubber stoppers around using the same apparatus we did before. The difference with this lab is we're testing a different variable on speed. Okay, so really, if you're smart and you listen carefully to what I say, you can save yourself a whole bunch of work by going to your other lab report and copying a lot of it over into this one. Okay, because a lot of the variables are the same. Okay, we're really only changing the manipulated variable here. Okay, and then of course one of the controlled variables, because one of the controlled variables in our last lab is becoming the manipulated variable for this lab. Okay, in our last lab, one of the controlled variables was centripetal force. This time it's going to be the manipulated variable. Okay, so there you go. I just gave you a freebie. Okay, so what we're going to do is essentially, like I said, the same procedure, except this time we're going to have a fixed radius on every trial. Okay, and that radius is going to be 40 centimeters. Right, so every time we do this, we're going to have a 40 centimeter radius. Each time we do it, we're going to have a different amount of weight hanging from the loop below the pipe. Okay, so we're whirling this around and seeing what happens. What do we have to do that with more and more weight on the bottom? Okay, all right, so that basically covers all the design stuff. Okay, because like I said, a lot of that you can copy and paste from the last lab, provided you did it right in the last lab. Don't copy and paste if you did it wrong. Okay, all right. For the hypothesis, okay, we want an if, and then statement relating the relationship between centripetal force and speed. This is a little bit tricky because according to the formula, all right, the formula looks like this. We know that if I change speed, that has an exponential relationship on centripetal force, but it is not true the other way. And in this lab, we're changing this to see its effect on this. Okay, so it isn't an exponential relationship. All right, but there is something other than linear in there as well. So it's gonna be a little bit tricky. Figure it out. You really only have three options when you do the graph. It'll become pretty obvious when you do the graph. Okay. All right. So we need the if part to talk about that relationship. Okay. Between centripetal force and speed, right? Because we said centripetal force is the manipulated variable. Okay. And you know what? Honestly, guys, it's okay if it's wrong in your hypothesis. Okay, you're not going to lose marks if you say in your hypothesis that it's exponential, as long as in your conclusion you say what it really is. Okay, most hypotheses, in fact, are wrong. Okay, it's what we learn from being wrong that is important. Okay, in the words of a very wise little green man, okay, the greatest teacher failure is. Okay, you don't want to take that too far. Okay, because failure is not good. It's okay to learn from it once in a while. Okay, all right, that's how science works though. Okay, oftentimes an experiment doesn't go the way someone expected and they learn something from it. So that's what we're looking for. Okay, the and part, as always, describes the experiment, and the then part should tell me what's your graph going to look like, okay? What's going to happen, okay? Kind of both of those things should be in there. What will happen to speed as centripetal force increases, and what's the graph going to look like? Okay, those are the two things that should be in the then part. Okay, so for our masses here, okay, we're going to start with just a 50 gram mass, so quite small. Okay, and we're going to put that obviously here. Okay, so we'll have like 50 grams, and then same as last time, 2 trials, but for each mass this time. Okay, add them together and divide by 2 to get your average time. Divide that by 20 seconds, or by 20 to get period, because it'll be 20 revolutions again, same as it was before. Okay, calculate your speed using 2 pi r over t, and calculate your centripetal force. How are you going to calculate your centripetal force? What's providing the centripetal force? The weight. What force is weight? Okay, so make sure that that's what you put in there. Okay, do not use this. Okay, that defeats the purpose of trying to test this. You can't use what you're testing in the experiment. Okay, we want to use that instead. Okay, that's what's providing our centripetal force. Spoiler alert, that might help you on the last lab report. Okay, all right. So you'll fill that chart in, and then you're going to make a graph of of centripetal force versus speed. Centripetal force obviously going on the x-axis. Okay. And then what did we say we're going to go up by each time here? 50 grams? Yeah, okay. Increase the hanging mass by 50 grams each time. So you go 50, okay, then you'll have 100. But I would put these in kilograms since that's what the chart says. Okay, so 0.5, or actually it should be 0.05. Okay, 0.1, 0.150, 0.2, 0.250. Okay, we don't want to get really, really heavy on here because the heavier you get, obviously, the faster it's going to whirl, and it gets kind of crazy when you get too much mass on that. Okay. All right. Yeah, so we're not going to repeat steps 6 to 10 until all masses are used, because that would mean we would go up to like the 1 kilogram mass. That'll actually break the string. So we're not going to do that. We'll just go up to 250 grams, and that will be lots. Okay. And then for your analysis, okay, most of your analysis is filling in the chart, which we've already talked about. Okay. For each trial, calculate the force of gravity. That's also still filling in the chart. 5, plot your graph. Okay. 6, what's the relationship? Tell me what it is. Give me some evidence for it. Explain it a little bit. Okay. Looking for, for sure a few lines worth of explanation there. Okay. Not just it's this. Okay. It's got to be explained a bit. Okay. Conclusion: copy and paste your hypothesis. Explain why you can accept or reject it based on what happened in the lab. Sources of error: same as last lab. I would think so. Yeah, they got to be pretty close to the same things. We're doing almost exactly the same procedure. Okay, so you can save yourself a lot of time. Realistically, there's no reason to not get this thing done today. Okay? I'm not making it due at the end of class. It's not due till next week, but realistically, there's no reason to not have it done. All right. Questions? Emily? No, it's just the analysis is just telling you how to fill in the chart. So, okay. Any other questions? All right. All the equipment is over there on the table, okay, except for the meter sticks, which are on top of the Chromebook cart. So just grab those and you can get started.